Welcome to Simulated Engineering. Let's start. A brief intro about FEMFAT on material data. So, we need material data to perform our fatigue analysis. That is first thing. Second thing is there are different types of materials you can use here. You can create materials. Suppose I create uh, Fe410, that is some kind of steel, and then if it is a steel, then what I will do is I will choose iron here, and if its ultimate is 410 MPa, I will choose a 410, and I will press enter. Through some empirical formula, it will automatically determine the pulsating alternating strength and yield values. And if you have yield values also, you can put it here. You can press OK. And if you have something what can I say, something like casted aluminum, okay, then you can use it here, aluminum, and then you can use aluminum casting alloys, and then ultimate, suppose it is having a 210 MPa ultimate, then you can press OK here. So this is how you can also create the casted aluminum material properties. So here you can see, uh, one second. Yeah, here you can see it is having the ultimate of 210 MPa Newton per square, and Young's modulus is 70 MPa. Okay, for steel, it is it is Young's modulus is correct, 210 MPa, and ultimate in strength is 410 MPa. Sorry, Young's modulus is 210 GPa, and aluminum Young's modulus is 70 GPa. Okay, gigapascals. Okay, and you might be thinking okay, I need to always create the materials. No, you are wrong. You can always export this material. Suppose I'm exporting it here in my directory. Suppose I'm creating it ffj files. Okay, and then you can create aluminum casted. Okay, so this has uh, exported it. I exported this and fe410. So these two files are exported. Okay, these two files are exported, and you can check it here. And how can you check this? So you can also check uh, in your text editor. So this data FEMFAT is using. Then the very next time, you don't even need to create the materials. If you and You don't even need to create the materials. You can directly import these things. Import, import, and go to your directory. Sorry, you can go to your directory and you can directly import these things. Press OK, and again you can go here and press OK. And these are text files, and this can be shared among your friends and in your team, in your organization, so everyone will use the consistent material properties. Okay, so this is how you can create the materials, and there are variety of material sets here. Suppose if you want to create wrought aluminum alloys, so you can go here and you can create wrought aluminum alloys. Uh, so this is how you can create the material properties in FEMFAT. Okay, there are wide ranges of material, and for each material you can see the SN diagram, SN curve, and you can also see the Hague diagram also for this. Okay, and this is how you can import the material, export the material. Okay, then the next question arises, how to use different materials in our fatigue solver. Suppose you have a deck here and these are two materials. So this circular part is steel and this part is our aluminum, that is casting. This is a machined part and this is a casted aluminum part. So firstly, if you want to use the FEMFAT, after solving the deck, you can again import the INP and you can create sets here. So for sets you can type, uh, suppose I am creating a element set. So always you need to create the element set for the FEMFAT analysis if you are having multiple materials. So you can type, you can create a set STFE410 and body 1, suppose. So I will switch this to elements and by this one by attach. So each and every element is getting recorded in this set, and then in next set I will do aluminum casted component. Any name you can give it, uh, just for, but you need to understand the component, like which name you have given assigned the sets to those components. So this is this and this is this body, and then one more set you need to create, that is first fatigue set, which will contain these two uh, all sets. Suppose there are two sets, so this will contain all the sets which we need to analyze. This should contain all the elements which we need to analyze. Okay, so these three elemental sets we have now. I will just uh, process this here. Suppose I have exported this. Once this is done, you can go to FEMFAT and you can go to FE entities. File format is abacus INP and you can read this. Okay. Once you read this, you need to go to groups. Okay, this is the element total element count. So once you got into the groups, you can see like there are some materials, some sets which we have created, and in FEMFAT those are called groups. So you can just add those groups in the FEMFAT groups uh, to analyze for the fatigue. So I am choosing this first set. This is first group. This is aluminum cast form, and you need to tick this option, check this option relate to elements in group, then click on add here. So this number of nodes have been added, and then you can go to FE410 body underscore body 1 and just click on add here. So this number of nodes will be added, and you can then select FEMFET set which contains all the elements, and you can just select this. And by the way, whenever you click on this, the nodes of these groups are added in the FEMFAT group. Okay, then you can assign the stress data. For time being, I'm not doing it because I'm just showing the how to assign the materials. Okay, so these two materials we have created, or you can directly import this one. We have already seen this. Then you need to again define the load spectra that you can do. Then you need to go to node characteristics. Node characteristics is nothing but the uh, you can say like the material assignment of those nodes. Those nodes belongs to which material the FEMFET wants to know. So firstly, this group is aluminum casted comp. Okay, and you the material relevant material whatever we have imported is aluminum underscore casting. Then comes the main part, that is the surface roughness of this. So surface roughness of aluminum casting component, this is a casting component. Okay, this component is casting component. Then So surface roughness is cast is 200 microns. And what is the influence of surface roughness in endurance limit? Anyone from the basic experiments and from our textbook, we know that as the surface roughness increases, our effective endurance limit decreases. So if uh, if a specimen without any notches or without any with a good quality surface will have more fatigue life. If you take a specimen with a rough surface finish will be expecting a less relatively less fatigue life. So casted components 200 micron, this will further uh, reduce the effective endurance limit. Then you can go to assign this material, this group Fe410, this is Fe410 material, and this is our smooth material. So if 60 microns is nothing but it is the surface roughness of a machined component. Okay, so this is a machined component. So surface roughness I put it 60 microns. This fatigue underscore set, you don't need to define any material here. Be careful with it. Okay, in the endurance now we can go to influence factor. So this influence factor, what is the use of this influence factor? So you need to like tick basic certain options here. So as we have used surface roughness, so the FEMFAT will adjust the uh, effective endurance limit. So you need to check this and surface roughness. Then in the last option, you can check this uh, mean plus amplitude unfavorable sequence as we have discussed it earlier. Okay, then you can simply go to analysis output parameters. Sorry, you can go to analyze and you can select this fatigue underscore mod and you can just click on analyze. Okay, so this is how you can uh, use this. You can use different materials in a single setting. So this set, what is the importance of this footing underscore set? This set allows us to solve for to solve for FEMFAT, to solve fatigue problem in a single run. So if I haven't created this fatigue underscore set, I need to solve individually once for aluminum casted component, once for Fe410. Now I can directly select this and I can click on analyze. It will solve for n number of materials. If I have created 10 materials and I will put those all material elements in fatigue underscore set and I will not define any material for fatigue underscore set except other groups. I need to define the materials and then I will click on analyze for this fatigue set. All the material fatigue cycles I will have this in the output. So this is how you can perform this. Thank you. Have a great day. Bye.